Hello everyone, and this is chapter 18, and this is the last chapter that we will cover for these 7 weeks. And then this chapter talks about the kinetics of a rigid body from work and then energy principle. And then if you remember, for this rigid body we covered chapter 16, and then we had chapter 17 and chapter 18 now. And there is chapter 19 that we will not cover. Chapter 19 and 16 was about the kinematics. So kinematics is just the geometry. Here you talk about the velocity, you talk about the position, and you talk about the acceleration. But here this is only the geometry. So it means that, for example, particle moves this way, and then this is the path. So you take d by dt, or you take d squared by dt squared. Okay, you just do geometric analysis. The chapter 17 was from force and then acceleration we talked about, and then we generally applied the Newton's second law. And then here we talked about the Newton's second law, and also we talked about the moments about any point, and then that will be equal to the moment of inertia times the acceleration term. Chapter 18, which is the current chapter, we will talk about the work and then energy principle. And then chapter 19, it is about the impulse and then momentum. But this chapter 19 we will not cover. Okay, so we will just cover chapter 18. So we have a simple experiment here, and then as you can see, so this one I talked about in chapter 17 as well. So we have a wooden solid cylinder, and then we have the hollow, maybe the metal cylinder, and they have the same mass. That this one is m1 and this one is m2. m1 is same as m2, but you can notice that the solid cylinder, it reaches earlier than the other one. Okay, the question is that why? Okay, why the solid cylinder reaches earlier than the other if they have the same mass? Okay, then the question comes as, we then answer that the kinetic energy of a body, till now we know that kinetic energy of a body is half mv squared. Okay, but if you have a kinetic energy of a rotating body, then you don't have mv squared, you have that half I omega squared. And this is the moment of inertia. Okay, and then for these two bodies, so one was hollow cylinder with a center of mass G here, and then we had a solid cylinder with a center of mass here, but it was a solid cylinder. And this one has a mass of m1, and this one has a mass of m2, and we said that m1 is same as m2. Okay, and then we have the same conditions. So there is something else that makes the solid one reach earlier to the end, and that something else is called the moment of inertia I. This one has a moment of inertia of I2, and this one has a moment of inertia I1. Okay, and then I, you can think of this one as a rotational mass, and then I2 is greater than I1, and that's the reason that second one reaches earlier. Okay, and also second one has higher kinetic energy. This is what we talk about. This is what we mean by a body with a rotational mass. I talked about this one in chapter 17, but here we will cover the kinetic energy of a rotating body. So I will just note a notation problems that the book, it uses two notations, which is T and then V. So, but in our slides, we will use the kinetic energy and then potential energy. This is potential energy and this is kinetic energy. And also the book uses U and then we will use the W, and this is for the work. Okay. This is the only difference that you may notice, because kinetic energy and potential energy notation is more user friendly than the T and the V. Similarly, the work is much better than understandable than the U, but sometimes we will just use the book notation. Okay, with this in mind, with this small introduction, then I will talk about a parade of formulas. These formulas are just, they are not the hard, but they are just a part of the chapter 18 that we need to understand what's going on in this formula.